Welcome back, AOM2316 students. Today we're going to perform a bench test on a starter. This is a starter off of a Caterpillar 247 skid steer loader. I believe we were having some issues with it, so what we're going to do is I've pulled this off of the machine, and we're going to perform a simple test on it to see if this is performing correctly. Really, the only thing we need is the starter itself and a good set of jumper cables. Of course, a battery, and we're going to use the battery on my vehicle here. And then I'll also be using our multimeter here to check some of the voltages. So we'll go ahead and get started. So the first thing that I'm going to do is we're going to connect our power supply, which is our 12-volt battery here, to our jumper cables. The skid steer is a 12-volt system, and my truck is a 12-volt system. So, meaning that it's compatible, will be compatible with the starter and should engage it. So I'm going to go ahead and hook up my positive and negative terminals, making sure that the other end, the other connectors are not touching each other. Alright, so a few other things about the starter itself. We have two components to it. We have a starter solenoid, and then we have the starter motor itself. So basically what this does, and as we've discussed in class, this solenoid is a electrical / mechanical component. So the solenoid is going to receive a signal from this stud here. Actually connects to the battery terminal, to the positive battery terminal on the vehicle or on the machine itself. Anyway, it's going to receive a signal from this device here. There's a wire that actually goes in here, and this wire is actually coming from a relay. So when you turn the key switch makes the connection to the relay. The relay sends power here to the solenoid, and this solenoid allows the connection to go from the positive side, or the hot side of the starter, and engage the solenoid. So the solenoid itself has a plunger on the inside. So once that's activated, it sends the electrical signal to the starter, to the commutator in the starter, and to the brushes. So as we know, in here we have copper windings and an armature on the inside, which engages the actual starter pinion in itself. So when this turns on, the pinion comes out and it spins, and this engages. The sprocket here actually engages on the flywheel of the motor, which engages the motor. And this is pretty much the same on gas and diesel motors. This is off of a diesel, obviously a Caterpillar. So that's a few of the things about this. So what we're going to do is, we need to test this to make sure this is working. So I pulled this out of the machine. So what we can do is I can, well, the first thing I'm going to do is I'm going to grab my other end of my jumper cables that we have connected to the 12-volt battery on my vehicle, and I'm going to take the negative terminal, and I'm going to, or the negative clamps, and I'm just going to clamp this to the just to the frame. So I'm just going to ground this out on the actual starter itself. This starter, so if the positive battery terminal is connected to this stud here, the negative on this one, this is actually a marine type starter, so the negative wire off of the battery connects directly into a stud off the starter housing itself. So we're going to go ahead and clamp our negative battery terminal here. The other end of the negative battery terminal is connected to the negative battery terminal on my battery in my truck. So, and I'll take the positive one, and I'm going to connect that to this stud again, because on the machine this would be coming directly from the actual battery on the 12-volt battery on the machine. So that's pretty much it to get started. So now it's still not on. Now it's still not on because it's just like if it was on your vehicle or still on this machine. We need to engage the key, so to speak. So what we're going to do is, well, first thing I'm going to do next, I'm going to go ahead and test it. So if we have pull out our multimeter again and see if I can position it in such a way where you can see. I'm going to turn this to DC volts, where this is a DC powered machine, so I'm going to turn it to DC 20. We're looking for around 12 or above 12 volts. Again, being a 12 volt system, we should be in that range. If you notice on my, if it will focus on it, the range goes from 2 volts, 2 DC volts to 20, and then 200, and then 300. We're gonna put our dial on 20 because again we're looking for 12, so it's gonna be the closest to the range that we're looking for. So I'm gonna go ahead and set this right here, and then I have our 2 leads connected to our multimeter. So the negative I'm just gonna put on the housing, anywhere on the housing of the starter itself to make good contact. And I'm going to take our positive terminal and I'm going to put it, and this is a bad spot, it's hard to see. Anyway, so our the stud that our power supply or positive terminal is connected to, I'm going to put it on there. And you can see the voltage coming off the battery on my truck running to the starter is about 12.7 volts. So we know that that's a pretty good charge, and that should engage this starter if it is working correctly. I'm going to go ahead and take this. Okay, so now we need to engage this. Now we need to make sure that we're hooked up correctly, we're hooked up to the battery, we're getting the proper voltage off of it. So I don't know if you can see this part here. So like I said before, there's a wire that actually connects here that receives the signal. So even though this is already supplying power, we need to receive a signal from a relay to engage this solenoid, to engage the starter and actually start the machine. So what I'm going to do is we're going to hot wire it. That's how we do a bench test. So I'm going to take a piece of wire, solid piece of wire, if you can see it, maybe like that, and I'm going to bridge the gap between the hot side of the stud here, so 12 volts. And again, taking the relay, taking the key switch and taking the relay out of the system, and I'm going to attach it to the bolt, or the bolt that's on the inside of this plastic housing. So if I can get a position where you can see this better, and then once we do that, this should engage. So this the starter pinion should pull out and should spin really fast. So we'll go ahead and do that. It's going to receive the full 12 volts. So I'll put 1. Please don't try this at home, because this is how do you hot wire a vehicle. But anyway, so we're on the positive side there, and actually there's a bolt on the inside of here. I'm just gonna go ahead and touch it, and I will complete the electrical circuit. So that's it. So we know that the starter is working correctly. It's receiving a complete 12 volts. And when this relay, when the solenoid receives a signal, it's engaging the starter properly. So I'll take this off. If this wasn't actually working correctly, it could be a problem with the solenoid in itself. So believe it or not, you don't have to buy a whole new starter in a lot of cases. You can actually just test the solenoid, and we could just replace the solenoid. Or it could be a problem with the brushes inside the starter itself. And typically what would happen is just this wouldn't engage, or maybe it wouldn't receive. You could have an issue with the brushes on the inside of the starter. There could be a lot of different issues with it. You can actually rebuild these. So I will actually, if there was an issue with this, I will take this to our shop in Ocala, and they can pull it apart and they can actually rebuild it, which is much cheaper than purchasing a new one. A few other things: the teeth on the sprocket here could wear down over time, engaging with the flywheel. There's just a lot of different issues that you could run into with this. So anyway, this seems to be in good shape. So I'm going to put this back on the machine, and hopefully we can get it working. Hopefully it was just a bad electrical connection somewhere.